This problem, or this set of questions, involve two different things. They are mixed together all the time. Expressing significant figures and SI unit using appropriate prefixes. So let's start with this one. In the past, when the only thing that we did was using the answer, the units, and putting that in the appropriate prefix, and now you have a quantity here. So look at these quantities. Let's evaluate each one of them. 212 millinewton square. In reality, what it says is 212 milli 10 to the negative 3 newton square. This is for the part A. So basically, when you solve this out of the parentheses, you have 212 square times 10 to the negative 3 square times Newton square. And the only thing that you have to do that is put that in the calculator now. Let's see what happened here when I put it. So 212 square times 10 to the negative 3 square. This is negative 6 times 10, oopsie doopsie. 10, 10 to the negative 6. And that's it. So you get the value of 0.044944 Newton square. Now, three significant figures. What are the three significant figures? The three significant figures will be this. Three significant figures. So I can say 1, 2, 3. There are so many ways that you can express this. So many different ways. These are Newton square. So you can say 4.49 times 10 squared Newton square. You can say 44.9 10 to the third, negative third Newton square. That's another way that you can say that. And all of those should be deemed valid as you are expressing that in three significant figures. And these are three significant figures. Let's say the part B. Part B is this one, millisecond squared, very similar. So 52,800 square milli square second square. Just put that in the calculator. 52,800 square times 10 to the negative 3 square is 10 to the negative 6. Enter, and that's 2,787.84 second square. Of course, for expressing this in significant figures, 1, 2, 3, these are my three significant figures here, and this is gonna round up the 2.78, so that will be 2.78, 3 decimals, times 10 to the third second square. That would be the solution for that one. And last but not least is basically the square root of this number. Remember, every number elevated to 1/2 is taking the square root. So that will be 548 to the 1/2, or square root, times 10 to the 6, 10 to the 6, 10 to the 6 elevated to 1/2, and then milliseconds. Millisecond in this time is outside the parentheses, so it's not affected by the square roots here. You see? That's why I kept it outside. Instead of putting millisecond, you can put 10 to the third if you want to here, 10 to the negative 3 second. But just keep in mind that this is not affected by the square root here. So we do this. 10 to the 6 to the 1/2 is basically 10 to the third, and this is the square root of 548. You can put that in the chain if you want to here and solve it. But I like simplifying things. So 548 to the 1/2 1 half is 0.5, so you can elevate it to 0.5 right there. Multiply by 10 to the 6 to the 1 half is 10 to the third, because 6 times 1 half is 3. So you can multiply 10 to the third. You can multiply by 1000 if you want to. And then you multiply by 10 to the negative 3. So basically this is 10 to the third, and this is 10 to the negative 3, and these two are going to cancel each other out. So I can even do better, and I can take this out from here. So let me take this out, and this will be the number that remains there, and the number that remains there is 23.409, let's say 4. Now the problem is telling you to, and the answer of course is in seconds already. And the problem is asking you to express it in three significant figures. There you go, 1, 2, 3 significant figures, 23.4 seconds. That would be the answer for that problem. It's just common sense. These problems are common sense, and some of them are not common sense at all, sadly. I don't like significant figures. I know they are important, but I really don't like. I like personally working with all decimal places that I can, rounding answers, and working like that. But hey, you have to learn it. You have to learn it. It's not me. Don't blame it on me. I'm just a messenger. See you next video.